Alright everybody, this will be the final video for this Unit 1 review problems worked out. So, we got question 19 left through 23, so it should hopefully go fairly quick. Problems 19, 20 deal with dilation. So, with 19 it says, what is the scale factor of the dilation above? So, keep in mind that whenever we're looking at dilations, we still always need to figure out which one is the pre-image and image. So again, we have this triangle, or quadrilateral on the right. We have just a regular E on the on the left, and on the right we have E prime. So this is our pre-image. This is our image. Now, the way that dilations work is you take whatever your pre-image is, so like EF is 10, and you multiply it by a scale factor, which we denote as K, and it should tell you what the length of your new, corresponding side will be. So this is 15. And we could rewrite this equation. So E to F is really 10 right here. K is our scale factor. E prime to F prime is 15. So we got 10 times K equals 15, or 10K equals 15. Now, to solve this for my scale factor, what I have to do is divide by 10 to cancel it off on this side. So that means that K is going to be equal to 15 divided by 10, which we reduce down to 15 divided by 5 is 3, 10 divided by 5 is 2, 3 halves, or 1.5. So our answer will be D. But just keep in mind that in order to figure out what a scale factor is, a scale factor K is always just some sort of image, so an after. So we could have done like 12 divided by 8 divided by your pre-image. So it always goes in this order whenever you're figuring out scale factor. So again, we could have done 12 divided by 8 to compare G prime F prime to GF, which again, 12 divided by 4 is 3, 8 divided by 4 is 2, so same scale factor. And you could also check with the other, so 6 divided by 4 would be the other. So again, divided by 2 is 3 over 2 equals 1.5. So D is going to be the scale factor for all three of those. All right, question 20. Question 20 says, determine the new coordinates A prime, B prime, C prime after the transformation dilation scale factor of 2 about the origin. So if you watched the dilations unit just recently, you should know that D stands for dilate. We have our scale factor is the first number written here, so our scale factor is 2 here. And then the O, the origin, the C is usually the center of dilation. In this case, it's the origin. On the test, I believe it's only dilating by the origin. But again, we could dilate by pretty much any point. The process is about the same. I'm not going to do the shortcut method this way. Actually, I could show both ways. But what we do for dilation is, since this is about the origin, I'm dilating every point about the origin. To get to A, I would need to go right 2, up 1. So now what I'm going to do is scale it by a scale factor of 2. So now I'm going to double those distances. So you're going to multiply or times it by 2. So instead of going right 2, now I'm going to go right 4. I'm going to double it. And then instead of up 1, I'm going to go up 2. So this is where A prime would be. And then if I do the same thing for B, from my origin or the center of dilation, which is this red dot here, I got to go left 2, up 2. So I'm going to double those. I'll go left 4, up 4. So this is where B prime would be. And then C prime, I'd go down 1. So instead of go down 1, I go down 2 because I'm doubling that. C prime. So these would be our new coordinates. We got -4, 4. We got 4, 2. And we got 0, -2. Now, the shortcut method, just in case you wanted to see that, is whenever we have a dilation about the origin. So we can only use this shortcut whenever this letter here is an O. If it's anything other than the origin, we can't use it. But the shortcut just goes like this. Figure out what the original points were at. So A was at 2, 1. B was at -2, 2. C was at 0, -1. And all you got to do, whenever it's about the origin, we can take the scale factor of 2 and multiply every single x and y coordinate. So A prime is going to be at 2 times 2 is 4, 1 times 2 is 2. And then B prime. Negative 2 times 2 is negative 4. Again, we're just applying the scale factor of 2 by multiplying it by 2. 2 times 2 is 4. See how these are the same points? And then C is 0 times anything is just 0. Negative 1 times 2 is negative 2. Alright, so I'll go ahead and fill those points in. So A prime is 4, 2. B 4, negative 4, 4. So 4, 2, negative 4, 4, and 0, negative 2. Perfect. Alright, question 21. Dealing with compositions. So there was a lot of misunderstanding about how to do compositions. I think a lot of people didn't bother to watch the video that I posted, so make sure that you're doing that. So again, with compositions, the way that it works is we always work from right to left. So if we're reading this example, it says we have this composition here. It's a composition of a reflection over the x-axis and a translation of right 6 up 3. So since we're working right to left with compositions, we would do the translation first. So we would first translate right 6 up 3. Then secondly, we would do the reflection over the x-axis. So that's true. That's how compositions work, always right to left. So we're going to basically do this for question 22. We have this triangle ABC, and we want to determine the new coordinates after a composition of reflection over the y-axis and a translation of 0, meaning that we're not moving left or right at all, and then down 3. So let me pull this up here. So the way that this works is, keep in mind that this is the first thing that we have to do, is we got to go down 3 first. So every single point I'm going to go 1, 2, down 3. So this would be C prime. B is 1, 2, 3. So this would be B prime. A would be 1, 2, 3. So A prime here. Then we reflect over the y-axis. So the y-axis is the vertical axis that goes through here. So then I would reflect all these points. So you don't really even need to graph these points in order to, you could just use your finger to go 1, 2, 3. And then reflect over the y-axis, 1, 1. So A double prime would be right here. Negative 1, 1. For B prime, we have it on the left side of the y-axis, so now I got to go right. So B prime would be 1, 1. Let me change the colors here. I'm going to change it to green. Alright, so this would be B double prime is at 1, 0. And then C is at 1, 2, 1, 2. C double prime is at negative 2, negative 2. And that's it. Those are your new points. So A double prime is at negative 1, 1. And again, this double prime indicates that there were 2 transformations. That's why we have 2 double primes instead of just prime, is because we're doing 2 transformations. So that's what these kind of primes represent here, double primes. So negative 1, 1, we got 1, 0. And then we got negative 2 for C. So compositions really shouldn't be terribly difficult, but if you have any questions about these, let me know. Last problem is question 23. So question 23, we have a composition of a translation right 4 up 2 after you do a reflection over the x-axis. So we got to do the reflection first in this problem. So a reflection over the x-axis will look like this. Oops. X-axis is the horizontal line, the horizontal axis right here. So to reflect over that, we got to go down 1, 2, 1, 2. So this would be C prime. B is on the x-axis, so it's just going to stay there. So that's where B prime is at as well. A is 1, 2, 1, 2. So that's A prime. So that's what we did for the y-axis. We got to do that first because we work from right to left. And now we're going to translate all these points right 4 and then up 2. That's what this means. So I'm going to go all these green points. I'm going to go right 1, 2, 3, 4, 1, 2. So this would be C double prime. B is 1, 2, 3, 4, 1, 2. And then A is 1, 2, 3, 4, 1, 2. So A double prime ends right at our origin. And we should get this new triangle. I didn't graph the last one. So you should notice that it looks pretty much the same as that other triangle. It's just reflected and translated. Exactly what we did to it. So we just flipped it and then moved it up over here. So A double prime is at 0, 0. And then we have B double prime is at 1, 2. And C double prime is at 3, 0. And that is it for the solutions. If you have questions about these problems, make sure you are asking. Thank you.